If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is A. Approximate f by a Taylor polynomial with degree n at the number a. B. Use Taylor's inequality to estimate the accuracy of the approximation when x lies in the given interval. And C. Estimate sine of 38 degrees. Here, f of x is equal to sine of x, a is equal to pi over 6, n is equal to 4, and 0 is less than or equal to x, which is less than or equal to pi over 3. Smash that like button and let's get started. We want to find the degree 4 Taylor polynomial of the function f of x equals sine of x centered at pi over 6. So in order to do that, we need to find the function evaluated at pi over 6 and the first 4 derivatives of our function evaluated at pi over 6. So our function evaluated at pi over 6 is 1/2. The derivative evaluated at pi over 6 is square root of 3 over 2. The second derivative of our function, which is the derivative of cosine, is negative sine of x. When we evaluate at pi over 6, we get negative 1/2. And now we'll just continue for a few more derivatives. The third derivative of our function is negative cosine of x. When we evaluate at pi over 6, we get negative square root of 3 over 2. So that's what's nice about these trig functions is we get a little bit of repetition as we take more derivatives. And finally, our fourth derivative is sine of x. So the fourth derivative of sine is the function we start with, actually. When we evaluate at pi over 6, again, we get 1/2. So in order to find the degree 4 Taylor polynomial, we just need 4 derivatives. So our degree 4 Taylor polynomial, which we denote t sub 4 of x, is equal to 1/2, so our function evaluated at pi over 6, plus square root of 3 over 2 times x minus pi over 6 over 1 factorial, so we won't write that, minus 1/2 x minus pi over 6 squared over 2 factorial, which is just 2, minus square root of 3 over 2 times pi over 6 to the third over 3 factorial. And then our last term is plus 1/2 x minus pi over 6 to the fourth over 4 factorial. So that's our Taylor polynomial. Now, in order to figure out how accurate our Taylor polynomial is as an approximation, we're going to need to take the derivative of our fourth derivative. So we need the fifth derivative, and we want to find what is its maximum value on our interval. Well, cosine of x is at most 1 on any interval, so we'll use 1 as our bound. And so we know from Taylor's inequality that our error is at most, well, this number 1 we just discovered, over 5 factorial times the absolute value of x minus pi over 6 raised to the 5th. Okay, the 5s come from the fact that it's 1 more than 4. And so we could use this. This tells us how accurate our approximation is. We could use our Taylor, our degree 4 Taylor polynomial to approximate sine of 38 degrees, which is T4 of 38 pi over 180, which when we plug that into a calculator, we get 0.61566. Make sure to subscribe for more coffee and math with Dr. Weselcouch. Don't text and drive. Bye-bye.